I'm going to be talking about the third problem from Chapter 14. This is from Section 5 of the chapter. Now remember, we're only going to cover Sections 2 and Section 5 of the chapter, which deal with P charts and X bar and R charts. And we've already looked at a P chart. We've looked at how to find the values, the control chart factors in the table. And now what we're going to do is actually construct a control chart for the range and the mean. And again, this is from Section 5 of Chapter 14. This is problem 1420, which is found on page 14-18. And notice the subgroup size here is n equals 3. That's very important because that's how we're going to find the control chart factors, is based on that number. And we've got 10 days on which we've taken observations. So here we have means and we have ranges. And if you remember, when you do these control charts, we have to begin with the R chart first. The reason for that is because we want to make sure the R chart is in control before we use the R bar value, or the average range value, in calculating the X double bar, or the average mean. If the range is not in control, or if we have a trend with the range, then we can't use that data until we fix that problem. So we start with the range, and if that looks okay, then we go on and do the test of the mean. So the questions say, compute control limits for the range. Is there evidence of special cause variation in A? Compute control limits for the mean. Is there evidence of special cause variation in C? So we used Excel to do this, or we can use Excel to do this. And this is PHStat. So notice the first thing we put in there is n equals 3. That is our subgroup sample size. So subgroup size is 3. So we put that in there. And notice it gives us actually the D3 factor and the D4 factor that we need to use. And it also calculates the R bar factor. So notice here's my observations. This is the table we're looking at here, control chart factors table. So this is a portion of the table. We have to be in the row that corresponds to 3 degrees subgroup size, and here are the values. D3 is 0, D4, capital D4 is 2.575, and A2 is 1.023. So those are the values that we're using from this table. And it gives us, for the R chart, the center line, 0.247. It gives us the lower control limit and the upper control limit. Okay, and this is based on our formula. Notice down here we're using those values. 1.023 is this A2 factor, and here's the other two factors that we're using in that intermediate calculation right there. And so here are the limits that we've come up with. 0.636 and 0 is the lower control limit because D3 was equal to 0. So that gives us a value of 0 for the lower control limit. And here's our center line. And so then, if we go back to the actual data, we can examine the range to say, are there any values that are outside of the limit of 0.636? And we don't have to worry about the lower control limit because we can't have a range value less than 0 anyway. So we look at the data and we say, are there any values more than 0.63? And there aren't any close to that. 0.46 is the closest we have. And the lower limit, again, we don't have to worry about. This is the smallest value, 0.13, which is not that close to 0. So therefore, it does not appear that there is any evidence of special cause variation. So here's how the actual computation would go. So here's the formula for the range, D4 times R bar, D3 times R bar. These are capital D4 and D3. And so here are the values we obtained from the table. Here's where R bar comes from, 0.247. And so we divide by 10, which is what? That is the number of periods on which we took observations. And that gives us R bar, which is right here, center line of R bar. And then we multiply D4, capital D4 times R bar, 0 times 0.247 is 0. And then 2.575 is 0.636. So that's our upper control limit. Again, here's where the numbers came from, and those are the calculations right there. Is there evidence of special cause variation? If we graph the data, this is what it looks like. It goes up and down around the R-bar value. There's nothing near the upper control limit or the lower control limit. It seems to be a random process. There's not any trend in the data where you have 7 points in a row above or below the average, or going up or going down. So therefore, there is no special cause of variation. That's part B. Then we want to find the control limits for the mean. Because everything looked okay with respect to the range, that's why we're able to go ahead and do the mean now, find the control charts for that. So the first thing to do is to calculate X double bar. And the way we find X double bar is, going back to the data, we add up all the means over here and we divide by 10, which is the number of days on which we took our observations. And so we end up with 479.98 divided by 10. And again, if you do it with PHStat, you can also find the average of the subgroup averages. So this is the sum, and then the average of the subgroup averages. The sum was 479.98 divided by 10 days gives us that figure. And then the A2 value comes from our control chart factor table again, 1.023. And so multiply that by R bar and add and subtract it from our center line. And that gives us the upper and lower limits for the control chart. And you can see those are the same here. If I did it with PHStat, I'd come up with the same answers right there. All right, so then the question is, well, are all the data within those limits or not? 47.745 and 48.251 are the two limits. So is there evidence of special cause variation in C? So what we did is we graphed the ranges, and this is where the values are coming from, is over here on the first page. Sorry, we're doing the means now. So we take these numbers and we put them on our graph with the center line in there and the upper and lower limits, and this is what we ended up with a graph that looks like this. And again, it seems to be pretty random around our center line. There's no out of control points. Remember, you only need 1 point to be above or below the limits in order to have an out of control process. So there are no values near the upper control limit, no values close to the lower control limit, no values, we don't have 7 values above or below the line or the average, or we don't have 7 going up or going down. So therefore, there is no special cause variation, and actually there is no trend either in this data.